In this video, we're going to take a look at Prim's algorithm. Now, in a similar fashion to Kruskal's algorithm, Prim's algorithm can also be used to find a minimum spanning tree. Now, the important distinction here is that Prim's algorithm considers vertices, whereas Kruskal's algorithm considers edges. Another difference here as well is that with Prim's algorithm, the tree always grows in a connected fashion, unlike Kruskal's algorithm. And in an exam, you could be asked to use Kruskal's or Prim's algorithm. So it is important that you do understand the difference here between the two different algorithms, right? So obviously, if the question wants you to use Prim's, you should obviously use Prim's. So it's important that you know which one is Prim's and which one is Kruskal's, right? But hopefully the previous video on Kruskal's algorithm and this video here on Prim's algorithm will illustrate the differences. So before we work through a practice question here, let's just formalize Prim's algorithm. So for Prim's algorithm here, it's pretty straightforward. There's simply 3 steps that we need to follow. So for step 1 here, we simply choose any vertex to start the tree. However, in an exam question, they will always give you the vertex to start at. The reason for that is because the examiner doesn't want to be marking tons of different questions with different starting points. So for that reason, they will always give you the vertex to start at. For step 2 then, we select an arc of least weight that joins a vertex already in the tree to a vertex that is not yet in the tree. And just note then, that if we have a choice of arcs of equal weight, we can just choose those randomly. So it really doesn't matter which you choose, it's completely up to you. And then for the final step here, step 3, all we simply do then is just repeat step 2 until all the vertices are connected. So like I said then, Prim's algorithm is pretty straightforward, just those 3 steps, and that gives us Prim's algorithm there. So that concludes this introduction here to Prim's algorithm. I'm hoping it sounds quite intuitive and obvious. If not, don't worry too much. I do think the example will help kind of demonstrate that. But yeah, like I said, that concludes this introduction here to Prim's algorithm. So let's just work through one practice question here for Prim's algorithm. So let's just have a go then at this one practice question here for Prim's algorithm. So as the question says, then use Prim's algorithm starting from A, that's this vertex here, to find a minimum spanning tree for the network below. We want to list the arcs in the order that we consider them and also state the weight of our tree. Right, so we're starting from this vertex here. So let me just do this in a different color. Let's just do it in green, right? So that's this vertex here. And what we want to do then is consider the arcs that link A to another vertex. So we've got a choice of 2 here, right? It's either going to be this arc here, AD, or this arc here, AB. What we do then is we choose the arc of least weight. So we're going to choose this arc here, AD. Okay. So I've included that on my diagram here. What we also need to do then is make a note of which arcs we're adding. So we add AD. So add AD, which has a weight of 8. Perfect. Now at this point here, we now consider then the arcs linking both A and D to another vertex. So I've got a few different choices here. I've got this vertex, this edge here, or this arc here, that's AB with a weight of 10. We've also got this arc here, BD, with a weight of 7. And we've also got this arc here, DE, with a weight of 7. Now, clearly, we're going to choose one of these 2 here. So either DE or BD, because 7 is less than 10. Now, out of these 2, it really doesn't matter which you choose. You can choose these arbitrarily, so it's completely up to you. So in this case here, what I'll do then is I'll add BD. So I choose BD here. So add BD, which has a weight of 7. And again, let me just include that on our network here that we were given. So we'll get something like that. Okay. Now, at this point here, we don't need to include A anymore in terms of considering that vertex, because if I was to choose this arc here, it'd form a cycle, right? So once you've included this vertex here, B, well, at this point here from A, all the vertices are connected. So we don't need to consider A, so we just kind of omit that at this point. So what I'm considering here then is both B and D. Okay, and again, all I do here is I consider the arcs from B and D connecting to the remaining vertices. Okay, so we've got a choice of 3 here, right? I've got this arc here, BE, with a weight of 6. We've got this arc here, DE with a weight of 7, and this arc here, BC, with a weight of 10. And again, all we do here is we choose the arc of least weight. So that's going to be this arc here. So again, let's just make a note, and I'll also include it on the network, like so. Going back to my original pen color then. We simply add BE. Okay, this has a weight of 6. Perfect. Now, again, this was the same network that we used for our Kruskal's algorithm video. So if you've watched that video, you'll be aware then that for a minimum spanning tree here, the number of arcs will always be 1 less than the number of vertices. We've got 5 vertices here, so we're going to have 4 edges. Well, I've got 1, 2, 3. So we're pretty much there, right? We just need 1 more edge here to complete the minimum spanning tree. So at this point here, D is connected to the remaining vertices, so we don't consider D. So at this point here now, we just consider both B and E. Well, I've got a choice of 2 here. We've got this arc here, CE, with a weight of 4. And we've also got this arc here, BC, with a weight of 10. Now, clearly, we choose the arc of least weight here. So we're going to choose then EC, okay, or CE, whichever way you prefer to describe that. So we then add CE. And this has a weight of 4, so let's not forget that as well. And I'll also include it on my original network, like so. Okay. At this point here, as we can now see then, all the vertices are connected. We have 4 edges, so we now have our minimum spanning tree. Perfect. Okay. And as you can see here, the minimum spanning tree that we've got for this question or this example is actually slightly different to the minimum spanning tree that we had for the Kruskal's algorithm video. And that can be the case, right? They're not always going to be unique, but what you should find here is the weight is the exact same as what we got in the Kruskal's algorithm video, okay? So let's just make a note then. Sorry, let me just go back to my original pen color. So let's just make a note then for the order of the arcs then. So arcs were added in this order. So what did I choose here? So I had AD, BD, BE, and CE. So AD, BD, BE, and then finally CE there. Okay, perfect. And what would be the weight then of this minimum spanning tree? So the weight here is equal to, so it's 8 plus 7 plus 6 plus 4. So 8 plus 7 plus 6 plus 4, that's 15, 21, 25. Perfect. And just notice here then, you might have forgot, but this is the exact same as what we got for the weight of the minimum spanning tree then in the Kruskal's algorithm video. Perfect, right? And that's exactly what we would expect here as well. Even though we're using a slightly different algorithm, Prim's algorithm is obviously different to Kruskal's, we should get the same weight here for our minimum spanning tree. Okay? And there we have it then. So hopefully nice and straightforward. That gives the solution to the 1 practice question for this video here. And that brings us to the end then of this video here on Prim's algorithm.